Hello friends, welcome you all to my channel. This video is about mathematics class 12 where I will try to solve some problems, selected problems from the very well-known and standard books on problem solving, which is NCERT at your fingertips. This is mathematics class, it comes in one volume that covers both the mathematics topics for class 11 and 12, and it's a good source of problems textbook for your board preparation as well as JEE preparation. So in this video I will try to solve some selected problems on the chapter integrals, which is in class 12. So the problems that I have chosen are based on the elementary standard integrals, properties of integrals, three special forms that I will discuss, and the basic integration by substitution. So let's get started. Okay, so I have a PDF, not PDF. I have written down all the standard integrals results that I will need to solve the problems. You can see on the left hand side, these are the standard results, and the standard results, some elementary standard integrals, and all the trigonometric formulas that will be need to be you need to be very familiar with all these formulas, because this will be frequently used in solving integral problems that has trigonometric functions. So I have kept as a reference all the formulas, and I will refer this list of formulas as and when required. So on the right hand side I will solve the selected problems. So let's start. The first problem is integral of 2 tan x minus 3 cot x whole square dx. Now to solve this problem, I will share my thought process because I'm not in a hurry. I don't want to solve this problem in a very short amount of time. I will share all my thought process and whichever direction I'm able to think to solve the problem, so that you will get an idea of the various methods and techniques you can use to solve a problem, because there are multiple ways of solving a mathematics problem. So my first thought process is that whether I will rewrite this formula. I will convert tan x as sin x by cos x and cot x by cot x as cos x by sin x. Now I can do that, and I will get a rational function of sin x and cos x. This is one thought process. Another thought process is that if I expand the square, if I do the squaring of this term, I can see that I will get a square plus b square minus 2ab, and ab will become 1 because it is tan x into cot x, and I will have tan square x and cot square x. Now tan square x, I can replace it with sec square x using the formula sec square x minus tan square x equals to 1. And I know the integral of sec square x. Also cot square x I can replace with what is I think it is 1 plus cosec square x. So I know the integral of cosec square x. So I think the second approach will be a better approach. So if I just do the squaring, I get 4 tan square x plus 9 cot square x minus 12 minus 12, because tan x and cot x will cancel. Okay. Now I will split the three terms into separate integrals, and I will bring out the constant outside, and I get tan square x dx plus 9 cot square x dx and minus 12 dx. Okay. Now I will again replace tan square x with 1 plus sec square x dx, and I will replace cos square x with minus cosec square x dx, and I have 12 dx. Okay, so now if I will over here I will have 1. So if I bring all the constant outside as a separate integral, I will have 4, 9, 13 and minus 12. So I will have like this, or dx, and then I will have 4 sec square x dx, and I will have plus 9 cosec square x dx. Please let me know if I am wrong anywhere, because I haven't seen the solution and I don't know the answer. I'm straight away trying to solve the problems. So if you see any mistake, any error, I will appreciate if you let me know that in the comment section. Okay, so now this is easy. This becomes x, and sec square x, the integral of sec square x I guess is tan x, and cosec square x, integral of cosec square x I guess is minus cot x, and we have this. So basically the answer becomes x plus 4 tan x minus 4 cot x plus constant of integration. Okay, fine. Let's do the second problem. This problem says integral of, it is a little bit complicated. It looks complicated, but I do not think the problem is in fact a difficult one. 2 to the power 2 to the power x multiplied by 2 to the power x multiplied by 2 to the power x. Okay, so seeing the structure expression, it is clearly visible that we have to use this result. We have to use what is that result? Let me quickly check the reference. Anyway, so basically we have to do a proper substitution, and we can clearly see that if we substitute, so we have this term 2 to the power 2 to the power x and 2 to the power x. So definitely if we substitute the whole thing, if we substitute, let's say, okay, let's let 2 to the power x equals to t. Now this implies if I differentiate with respect to x on both sides, I get, so this is basically 2 to the power fx. When you differentiate a function of the form 2 to the power fx, it is basically we have to use the result of a to the power x. So a to the power x, differentiation of a to the power x is a to the power x into log a. So this will become 2 to the power fx into log 2, and we have to differentiate this f dash x fx. So using this concept, if I differentiate this, both side with respect to x, I get 2 to the power 2 to the power 2 to the power x into definitely a log 2, obviously with base e. So this becomes the differentiation of the whole thing. Now I have to again differentiate the power of the base 2. So I have to differentiate this one. When I do that, I get 2 to the power 2 to the power x multiplied by log e2, and then again I have to differentiate this one, which becomes again 2 to the power x into log e2. So this and dx equals to dt. This implies now this whole thing was t, and I get log e2 3 times. So log e2 cube, and let this remain because I already have this in the integrand. I already have this in the integrand, so this becomes this. Now if I do the substitution in the original integral, I get now the integral becomes, so okay, so I substitute, okay, so this becomes t into now what is dx, what is 2 to the power, I will substitute this thing in the integral, which becomes, let's do one thing, let's write the solution a little more step by step. Now this implies this implies log e2 cube into t, this implies 2 to the power x into 2 to the power x dx equals to dt by t log e2 cube. Okay. Now if I do substitute this thing in the given integral, I get the first term factor was t, and the second becomes dt by t log e2 cube. Okay, I hope I am right. So this essentially becomes, t cancels out, this basically becomes log e, but this is a okay, so this is the constant. I'm going to bring out the constant outside, and it becomes q plus c, and if I now replace t with what we have substituted t for, it becomes 2 to the power x divided by log e to 3 plus the constant of integration. Okay. Please do check if I am wrong anywhere and let me know in the comment section. Let's do another problem. This one says 10x to the power 9 plus 10 to the power x log e 10 divided by 10 to the power x plus x to the power 10. Okay. So my initial thought is to check what becomes the differentiation of the denominator if I put 10 to the power x plus x to the power 10 equals to t. This implies differentiate, if I did, and then differentiating both sides with respect to x, we get 10 to the power x log e 10 plus 10x to the power 9 dx equals to dt. So we got this thing is already in the numerator, so it's easy. So if we now do the substitution, we get this becomes dt by t, where we have substituted 10 to the power x plus x to the power 10 equals to t, and when differentiating we got x 10 to the power x log e 10 plus 10 into x to the power 9, which is already there in the given integrand in the as the numerator. So this was easy. Now this is log mod t plus c, log mod t plus c, and let me check if I am okay. Don't have the elementary standard results anyway. So 1 by t, integral of 1 by t is log mod t plus c, and t is mod, so t is 10 to the power x plus x to the power 10 plus c, and we can remove the mod because any exponential function 10 to the power x is always positive, and also x to the power 10 no, x to the power 10 can be negative if x is a negative, if x is, yeah, it is also positive. So I think we can remove the mod and we can say the answer is log of this. Okay, so let's see the next problem. Okay, so the problem is sin square x divided by cos x to the power 14 and whole power 1 by 3 dx. Okay, so now to solve integrals which contains only sin x and cos x and some power either together or as a rational function, I think most of the time, most of the cases, we need to substitute cos x equals to t or sin x equals to t. That could be one thing, one approach. Or another approach is if we can simplify the given term and do a simplification and rearrange terms and do reduce the complexity of the term into more simpler form, then we might get some standard results. I mean, we might get some expression where we can use some standard results. So over here we have sine square x by cos x to the power 14 and whole power 1 by 3. So I am thinking if I can split the cos x to the power 14 as cos square x and cos x to the power 12, then I can merge the cos square x with the sine square x, and I have cos x to the power 12. Okay, now what next? Now sorry, my microphone just fell off. Okay, now cos x to the power 12 and whole to the power 1 by 3, we can reduce that to cos to the power cos x to the power 4. So this becomes essentially tan square x into 1 by okay, this becomes sec x to the power 12 and whole to the power 3. I have a feeling that I have to substitute tan x equal to something, because let's see, I have some even power of sec x and I know the integral of tan x is sec square x. Let's see, and so this becomes essentially, if I also do the powering of 1 by 3, I get what do I get? I get tan square x to the power 1 by 3, and I get sec x to the power 4. Okay, sec x to the power 4. Okay, now when you have some product of tan square x, I mean some even power of tan x and some even power of sec x, I think definitely if I now at this stage, if I substitute tan x equals to t, what will I get? Tan x equals to t, I will get sec square x dx equals to dt. Should I at this stage should I substitute tan x equals to t? This implies sec square x dx equals to dt, and this x to the power 4 we have. So 1 sec square x dx, we can substitute that with dt and we will left with sec square x. We can substitute sec square x with the 1 plus tan square x, and sec square x is 1 plus tan square x. Sec square x is sec square x 1 plus tan square x. Should I substitute tan x equals to t at this stage? Let's see what happens. If something goes wrong, I will fall back to another approach. Tan x equals to t, so we have sec square x dx equals to dt. Okay, so the integral becomes let tan x equals to t. So we have so we get tan square, we get t, this we get, and sec square x dx equals to dt. So over here, if we split sec x to the power 4 as sec square x into sec square x, we will get dt into sec square x, and sec square x is 1 plus tan square x, which is 1 plus t square. Okay, so I have got 1 plus t square t to the power 2 by 3 dt. Okay, this is easy now. So this becomes integral of tan 2 by 3 dt plus what is this, t 4 by t to the power 4 by 3. Okay, now this becomes if we take the integral, t to the power integral of t to the power n equals to t to the power n plus 1 by n plus 1. So this becomes t to the power 5 by 3 into 5 by 3, which is 3 by 5, and this becomes t to the power 7 by 3 into 3 by 7 plus c, constant of integration. So now we can substitute back t as tan x. So we get the answer as 3 by 5 tan 5 by 3 x plus 3 by 7 tan 7 by 3 x plus c. Okay, let's do the next problem. Let's do this one. We have sine 2x and sine of x minus pi by 3 into x plus pi by 3 dx. Okay, now in general the approach is when you have some trigonometric function sine cos or cos sine cos in a product form in the denominator, and you have a single trigonometric term sine or cos in the numerator. The standard approach is to split the angle of the sine or cos of the numerator with the angle of the sine and cos terms from the denominator. So we can clearly see that the angles x minus pi by 3 and the angle x plus pi by 3, if we add them, we get 2x, which is the angle of the sine in the numerator. Okay, so I can write sine 2x as sine 2x as x minus pi by 3 plus x plus pi by 3. I can like this, I can write like this, and the denominator we have. The idea is to rewrite the angle of the sine or cos term in the numerator as in the form of a plus b or a minus b, so that we can expand that using the formula sine a plus b or sine a minus b or cos a plus b or cos a minus b, and if we write the formula, then some terms will cancel out from the denominator. So now if I use we have in the numerator sine a plus b form, Now if I expand that using the formula sin A plus B, which is sin A cos B plus cos A sin B, this becomes sin A cos B plus cos A sin B. And we have in the denominator these two terms. Clearly we can see that some terms will cancel out. If we split the numerator into two terms, we have A plus B in the form of x plus y, sorry, A plus B. If we split that into two individual terms, we get, so from the first term, sin of x minus pi by 3 will cancel out, and we will get cos x plus pi by 3 divided by sin x plus pi by 3, which is cot of x plus pi by 3 and dx. And from the second term, we can see sin x plus pi by 3 is cancelling out, and we are left with cot x minus pi by 3. So now we know the integral of cot x. The integral of cot x is log of sin x. So using the standard result, we can say this integral becomes log of mod sin x plus pi by 3, and this becomes log mod of sin x minus pi by 3 and the constant of integration. Okay, now you can merge the two log terms. I hope I did it right. Let me check once again. Sin 2x is x minus pi by 3 plus pi by 3. We have sin A plus B, which is sin A cos B, sin A cos B plus cos A sin B. Okay, now over here sin x minus pi by 3 cancels out, we get cot x plus pi by 3, and over here we get the second term sin of x plus pi by 3 cancels out, and we get cot x minus pi by 3. Okay, fine. Now if you you can also merge the two log terms, and this we can further simplify. We can merge the two log terms into single log terms as sin x plus pi by 3 and sin x minus pi by 3. We can do this. Okay, let's do a final problem. What we can do? A final problem. Let's do this. We have cot x and cube root of sin x dx. So cot x divided by cube root of sin x dx. Okay, so if we replace cot x by cos x sin x, if we rewrite the given expression in terms of sin x and cos x, what do we get? We get cos x by sin x to the power 4 by 3. Yeah, I think this is pretty easy. We can simply this thing, and we have over here cube root of sin x. Now this we can easily substitute sin x equals to t, and the difference cos x is already there in the numerator. So cos x, and this becomes 1 plus this is 4 by 3 x and dx. So we can now substitute substituting cosec x. Okay. If we substitute sin x equals to t, we get cos x dx equals to dt. Therefore, the integral becomes dt by t to the power 4 by 3. We get now this is t to the power minus 4 by 3 dt. This becomes plus 1 minus 4 by 3 plus 1. How much is it? Minus 1 by 3. So this becomes minus 1 by 3 divided by t to the power n. I am applying the result. Integral of t to the power n equals to t to the power n plus 1 by divided by n plus 1. So okay. Now this is minus 3 by this is cube root of t plus c. This is minus 3 cube root of sin x plus okay. I hope I did it right. Let me check. If I differentiate this thing, am I getting the integrand? Sin x minus of sin x to the power minus 1 by 3 minus 1 by 3 and minus 1 by 3 minus 1 minus 4 by 3. Yeah, I think it is. We are getting. So that was all for this video. In the next part, I will try to solve more problems, selected problems from this textbook, NCERT FingerTips, NCERT at your fingertips. They have some good selection of problems. They cover PYQ of JEE, and the most of the problems are basically taken from the PYQ of JEE mains, maybe advanced, and the NCERT textbook and the NCERT exemplar. So that's all for this video. If this video was beneficial to you, then please consider supporting my channel by subscribing to my channel, like this video and share this video with your friends, and please do not forget to press the bell icon so that you will be notified by my future videos. Thanks for watching, and until the next video, take care and bye.